All right, so we're going to have some fun tonight. We're going to go through some slides, but we're also going to do some live coding. I'm feeling dangerous, especially in front of a large crowd. We'll do some live coding. We'll see how it goes. My name is Dan Vega. I'm a Spring Developer Advocate at Broadcom. Tell you a little bit about me. I'm a husband and father. I live outside of Cleveland. I was recently named a Java champion, which was very, very exciting for me. That was a lifelong career goal, so that was a lot of fun. I've been doing this a while. I hate putting this number on here, but I've been doing this for about 23 years now. Worn many hats in this industry. I think this is my favorite hat that I've worn, though, because long before I was getting paid to do so, I was a Spring Developer Advocate. I'm a content creator. You can learn more about me at danvega.dev. I also enjoy running and golf. Now, we have this little show, Spring Office Hours. If you haven't heard of it, it's a live stream. We do it every Monday from 1 to 2 Eastern. We also turn it into a podcast. The idea behind this show was to really help the community stay up to date with all the things that are happening in the Spring ecosystem, because it's not just Spring Framework and Spring Boot. There's a lot of things going on. So we kind of keep you up to date with what's going on as well as answer questions. So if you're interested, check that out. So what we're going to do tonight, I want to do a quick kind of level set of what happened in Spring Boot 3.0. There were kind of 4 major themes there with JDK 17, Jakarta, AOT, and observability. Then we'll go into Spring Boot 3.1. It was a point release, but there were some really interesting things in that release, one of which I'm going to dive a little bit deep into today, which is the Docker Compose support. And then we'll talk about 3.2, which came out in November. We'll talk about some of the runtime efficiencies, so virtual threads that came in JDK 21, the initial support for Project Crack, and the new client abstractions, both the JDBC client and the REST client. And we'll talk about them at a kind of high level, and then we'll dive in and do some coding with them. So real quick, Spring Boot 3, kind of touching on Java and Jakarta. You know, when we first kind of announced that Spring Boot 3 was going to be baselining on JDK 17, you know, we had a lot of people throwing their arms up saying, oh my gosh, we got to move off of Java 8 now, right? And at the time, it may have seemed a little bit aggressive, right? But as you can see, November 2022, when Spring Framework 6, Spring Boot 3 came out, we were already getting ready for JDK 20. So here we are today. JDK 22 came out. Java is evolving, moving fast every 6 months. So to get onto Spring Boot 3, you need to baseline on JDK 17. The other big change was with Jakarta. So we have this new namespace from Java EE to Jakarta. This just means that if you're using certain packages like javax.persistence, you need to move to a new namespace like jakarta.persistence. This was a big thing. It's kind of an annoying change, right? For you to have to change this in your projects. It was a bigger change for us in the framework to make this change, but it was something that had to be done. We need to make this namespace change because all evolution of the APIs are going to happen in the Jakarta namespace. And I, for one, am excited because this was really stagnant for a while, right? There were no changes happening there. And now we start to see Jakarta EE10 come out. Jakarta EE11 is coming out later this year. So we want to be on that. Now, the good thing is there are tools to help you support this change. You don't want to just go through and do a find and replace because there are JavaX packages that you don't want to replace, right? So you can use something like IntelliJ IDEA has a really great migration in there built into the IDE. There's a really great tool called Open Rewrite, if you're not familiar with it, where I'm going to try and get to an example of that tonight. And then there's the Spring Boot Migrator, which is built on top of Open Rewrite. So that's Java and Jakarta. The other big change was ahead of time compilation. I'd like to know, like, what is this? Why should I use it? So I want to quickly talk about that. AOT compilation is all about reducing the startup time and the memory footprint of our applications in production. This was a precondition for something like building GraalVM native images. So there is a trade-off here. There's an extra build step involved, but at the end of the day, we get this container or this application that will start up much faster and use a smaller footprint. So why would we want to do this, though? Well, we get instant startup, so milliseconds instead of seconds, right? We have no warm-up. We don't need to warm up an execution environment. We have things like lower resource usage. Because the memory footprint is lower, we don't have to have as many resources in that environment. There are, when we talk about AOT and compiling to a native, we kind of tell the compiler that these are all the things that you should assume at runtime, right? So because of that, we do have a reduced surface attack as far as security goes, because we're not doing these dynamic things at runtime. All this leads to a smaller package, and if we are using smaller containers in production, we have lower compute costs. It may not seem like that on one instance or two instances, but if we're doing something like 100 or 1,000 instances, this is really going to add up. So I like to talk about use cases, and I like to start with, like, where would I use this AOT? So any scenario where I have lower memory, lower CPU, this is a good use case. Function as a service, as we know, is a big use case for this. So if I'm building something that I want to deploy to something like AWS Lambda, Java's never really been a good environment for this, right? Because we have to warm up a JVM and wait for that startup to happen to be able to deploy, to run our function. So what I want is I want a faster startup time so that when somebody sends a request in, I can immediately act on it and return a response. So function as a service is a really good use case for this. On the same vein, scale to zero, right? If my application doesn't need to be up and running all day long and take requests all day long, this is something like, I always use the example of, like, if I was writing a newsletter subscription, I probably get 5 to 10 newsletter subscriptions a day. This isn't something I need to be running 24/7, right? I can just write a function to take that request in, save that off, persist it to a database, shut down, and then wait for another request. I was working on a side project, and somebody asked me, like, where are you going to host this side project? And I said, probably on something like AWS Lambda. And they're like, well, or AWS. And they're like, well, isn't this going to cost a lot of money at first if you're not having like a lot of throughput and a lot of customers? And I said, yeah, if I put it on an EC2 instance that has to be up all day long, yes, it's going to cost a lot. But if I put it on something like functions as a service where you can just take a request and shut down, then no. So this is a really good use case. Something else I've been doing lately is building CLIs in Spring. I don't know if you know that you can do this, but Spring Shell allows you to write CLI applications in Spring. Normally you could do this in something like Bash, but I don't know about you. I would have to like ChatGPT how to do a for loop in Bash at this point, because I just don't remember it. So I want to be in an environment that I'm used to using every day, and that's Spring. So now I can write little tools in Spring Shell, compile them down to native so that they run right on my machine, and that's been a really good use case for me. Places where you may want to assess, and when I say assess, hey, take one of your applications, see if this is going to help out. Things like microservices, containers, maybe a back office application that doesn't get a lot of throughput, maybe that's not a good use case. Where the JVM is likely better, and there are definitely cases where they are, is something like a high traffic website, right? Where you have large amounts of CPU and memory. If you're doing frequent deployments, because again, I said there is a trade-off with AOT, right? There is an extra build step there. These big monolithic applications. The JVM is really good at optimizing for these types of applications. It looks at your code, it sees what's getting used a lot, it's able to compile them and improve efficiency there, right? So I like to show this off because, again, we'll talk about some more later with like virtual threads and Project Crack, but all of these things are just ways that you can get your applications into productions for the different workloads that we're working with, right? Because we're not all like building the same application and putting it into production. So that's AOT. Another big theme in 3.0 was observability. What is observability? Observability is the ability to observe the internal state of our system, right? This is logging, metrics, and usually kind of distributed tracing. There are some changes that happened in 3.0, one of which was with Micrometer. And now we're doing a bunch of observations on the things internal to the framework. So if you make like a REST template callout or a REST client callout, we are automatically instrumenting those. So if you add the actuator to your application and you go through and you're doing these things, we're adding those metrics to it. So you can get those metrics out of the box for free now. Also, you used to have to add a different dependency if you wanted to do distributed tracing. You had to bring in Spring Cloud Sleuth. You no longer need to do that. That's kind of built right into the framework. One of the most important changes might have been the observation API. So the idea is that you might want to instrument your application, your components, your code base. There are a bunch of things that you have to do when you observe your code, right? You may want to like emit log messages. You may want to start and stop timers. You may want to increment counters, start and stop spans, signal errors. There's some things you have to do in there. So API that is being used by the framework underneath the hood is also available to you. Now this one is a little verbose, but I wanted to show this off first. So you can come in and use the observation API to say, here are some key value pairs, and that observe is what we're going to actually observe. I'm just logging something there, but now we're observing that. So now you can like start to observe your own code. We can also shorten this if you add AOP to the class path, and you can just add that @observed annotation. So now anywhere in your code you want to get some metrics on, you can do that. You don't have to do all those steps that I was talking about before. So that was my quick kind of rundown of Spring Boot 3. There were some other great additions. HTTP interface clients, we'll see an example of that tonight. RFC 7807 around problem details is about just being able to add more information to your error responses. There were some big changes in Spring Security 6, and Spring Data, and Spring Authorization Server, and more. So that's Spring Boot 3. Just kind of wanted to level set where we were with that. Spring Boot 3.1. Again, I said there were some really great features in this that kind of came out of 3.1. And I want to start with this scenario, and I think we've all kind of been here. How many people have gone and like started a new job and you get that really long README doc of like these are all the things that you need to set up to start running our app, right? Hey, maybe we need Postgres and we need Kafka and Redis, and oh, there's all these other microservices you got to talk to as well. This is also a scenario where you might be doing this in the open source world. You want to like run this open source project on GitHub, and you go and you look at this README doc and you're like, I don't have time for this. I got better things to do than set all of these things up, right? So what we're trying to do is get away from this long README setup doc to more of a, I just want to git, clone, and run your project, right? I don't want to have to like set up all these dependencies. And this is where some of the developer experience comes in with Docker Compose, test containers at dev time. And this all revolves around this interface called the connection details. Is everybody familiar with Docker Compose? All right, we'll go through it. So Docker, a way to kind of containerize applications. There are two sides to Docker, right? There's the Docker Compose side where I want to say, hey, this application needs a database, but I don't want to set it up. So I can write a Docker Compose file, run that, and now I have a Postgres database running. There's the other side of this, which is building containers for runtime. This is more on the Docker Compose side. So what happens is if you go to start.spring.io and you fill out your application and you say, hey, I want to build a web app. I'm going to use Spring Data JDBC, I need a PostgreSQL driver, and I'm going to use the Docker Compose support. What that Docker Compose does is look at all the other dependencies that you've included and said, okay, I know how to write services for that. So it writes a compose file for you. This one, probably a little hard to see, but all it says, it defines a PostgreSQL service. We'll see an example of this in a minute. Now what happens when you start your application up, I mean, how many people have gone through this before? Because I know I have. Before Docker Compose support in Spring, I would have a Compose file, I would start my Spring app, realize my PostgreSQL database wasn't running, so I just stop it, run Docker Compose up, and then start my Spring app. What this does is it, by convention, will look for that Compose file. If you want to put it somewhere else, there's a way to tell it, like, hey, this is where the Compose file is. It will see it, it will look for all the services that you've declared in there and run the Docker Compose up on those services. So now, just starting the Spring app will start those up. It also does a couple of other interesting things. One, you don't have to run Docker Compose up, but if for some reason you had that service already running, it will realize that and not interfere with that service. The other big thing for me is that you don't have to duplicate properties. So it will see your database username, your password, your database name, and it will inject those into a property source at runtime. So you don't have to redeclare those in application.properties, which is really nice. Now the question comes with this, like, how does this work? How does it read the Docker Compose file? So I told you we have this Compose file. What's on the bottom is what we're used to writing, right? So we have to set up a URL, a username, and a password. So how do we get from that to that? And that is through this interface called the connection details. And if you notice, what I find really interesting about this is there are 3 authors on this empty interface, which is interesting. I don't know what they were talking about when they put this together, but we should find out. So there is this connection details interface, but if you go in and look at the implementations for this, one of which is the JDBC connection details, that's an interface. There's a properties JDBC connection details interface. And so that knows how to look at that compose file and basically inject those into a property source at runtime. So I find that very useful. Also in 3.1, there was test containers at development time. So if you were using test containers, so test container is this nice way to like spin up a container for a test, so that we're not using in-memory H2 databases for testing anymore. We're using something more that looks like production, right? We were doing that, but it was like, okay, well, I have this test containers thing running. Now when I'm writing in development, I don't have that thing running. So how can I kind of use both of those? So a lot around test containers, Docker Compose. There are some nice features around building Docker images and more. So that was Spring Boot 3.1. Now I want to jump into Spring Boot 3.2. So this came out in November of last year. And one of the things I like about our release notes is they're all pretty similar. So when a new release for Spring comes out, check out the release notes. It tells you, okay, if you're coming from a previous version, here are the things that you need to know. Here are the new features that we're introducing. And here are any things that might have been deprecated to understand. For 3.2, I kind of combine these into like three big buckets. Runtime efficiency, so we added first-class support for virtual threads. We'll see an example of that. The initial support for Project Crack, we'll talk about that as well. And the new client abstraction. I'm a big fan of the REST client and the JDBC client, and we'll do some live coding around that. So, runtime efficiency. Project Crack. Similar goals to AOT, right? Like with AOT, we really want to get that startup time improved. Project Crack stands for Coordinated Restore at Checkpoint, and it just goes about it a different way. So when a Java application's kind of starting up, it has this curve, right? So it's coming up, 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 and then it kind of flatlines. When we hit that flat line, we take a snapshot of it, and we say, okay, we have a snapshot of your application. Now we can go ahead and restore from that checkpoint whenever we want to. Now you're probably thinking in your head, wait a minute, there are things that happen in my application that maybe I can't snapshot, right? Like maybe getting secrets from a vault or talking to a database using database connection details. So there is an API, a way to get those even from the snapshot. But again, the snapshot is all about increasing that startup time, not having to like wait seconds. One of the examples that I've seen out there is the Spring Pet Clinic starts up in like 5 seconds. With Crack, it starts up in like 400 milliseconds. So just another way to increase that. Again, a lot of these are about the different types of workloads we're trying to get into production. And yeah, Spring Boot 3.2 adds initial support for this. One of the things it can do is you can turn on a flag to say, hey, go ahead and take automatic snapshots of this. So there's a way to configure that in 3.2. Okay, so Project Loom. I don't know about you, but for me, Project Loom, virtual threads, probably one of the biggest features in the JDK for as long as I can remember, since like JDK, at least for the type of applications that I'm building, that I'm talking to customers about, this is going to be a big deal. So I think we should start with what is a thread? What is a thread in Java? Really, Java is multi-threaded by default. A thread is really just a wrapper around, whoa. I don't know why IntelliJ stopped. Cool. So a thread is really just a wrapper around an operating system thread, referred to as platform threads. And platform threads are really expensive to create, right? They're finite resources. So it takes a lot of memory, takes a lot of time to create and destroy. Traditionally, threads are stored on the JVM stack. So along came Project Loom. This just didn't come out of nowhere. This has been worked on for a while. If you've been around Java for a long time, you may have remembered something called green threads, which was a similar attempt at this problem a long time ago that didn't really work out. But Project Loom came along and said, hey, I want an easy-to-use, high-throughput, lightweight concurrency model. How can we tackle this? So Project Loom is a collection of JEPs, JDK enhancement proposals. Virtual threads went final in JDK 21. There are 2 others that are part of this that are interesting around structured concurrency and scope values. Those actually just went into another preview in JDK 22. I was hoping we'd get these in 22, but it looks like they're going to be around again. So hopefully we'll get these in 23. But the big one was virtual threads. So what is a virtual thread and why should we care about it? The big thing is it's no longer linked to an operating system thread. I said those operating system threads are a finite resource. Threads in Java are also very expensive to create. Not these. These virtual threads are not linked to an OS thread, so when it needs to do a blocking operation, like talk to a database or talk to another service, it can detach itself from that process, let it go do its thing, and something else can reattach it to it later. So they're very lightweight, they're easy to create, they're fast. You can create thousands, millions of them. It almost gives you an illusion of infinite scalability. It's a weird thing to say, but it does, and it's not infinite scalability, but it is a much higher scalability when we talk about the things that we're doing in web applications, right? So why do we care about that as kind of web developers, right? Building web applications. So let's look at an example. We have this Java app, it's running Spring, it's talking to a database, and maybe talking to input-output, maybe talking to another service over HTTP, maybe talking to some JMS, which is blocking as well. Everything seems to be working good until we get it out into production, right? Now we're taking in all of these requests, we're getting high throughput, and things start crashing, and we're like, what is going on, right? So that really comes back to the way the thread per request model works in Java, or at least on a web server side, right? When a request comes in, it will, again, we know that a thread gets created. That thread is a wrapper around an operating system thread, and that thread will be in use until that blocking operation is done. So it's got to talk to the database, it's got to get its response, then it's free to go do whatever else it needs. So these are finite resources. When the maximum number of these threads are in use, then everything is kind of waiting around. Like we cannot take another request until these things are freed up. So again, Java's made of threads, wrapped around OS threads. So in the past, when we've hit this problem, we've had a couple of solutions to this, right? When we want to scale our applications, we can do it one of two ways. We can talk about hardware. We can say, hey, let's scale this vertically using memory, more CPU, or let's scale it horizontally and throw more servers at this as a solution. Another solution we've had is asynchronous programming. In the Spring world, we have reactive Spring, and there are some pros and cons to this, right? Some of the pros are you're kind of using your resources more. You can deal with large data sets more. Some of the cons are it's all or nothing. There is no mixing and matching, right? You're either a reactive app or an imperative app. It can also be a little bit of a learning curve. Who's ever looked at reactive code and goes, whoa, that's a little bit confusing to me. Don't worry, I'm one of those people. You can raise your hands. It's a little bit confusing, right? So it's like a different mind shift to get your head around. And again, it's not mixing and matching. It's like, I got to use this. I got to use all of this reactive code. And it can be harder to debug and find out what's going wrong. So in come virtual threads. Again, we have all these tiny, lightweight threads that we can use that are not blocking operations. What does that mean to us as Spring developers? This means if we're writing our web applications, and in our web applications, we're doing blocking operations, like talking to databases, talking to other services. That means in these types of applications, we can expect significant scalability benefits. And that's really exciting. What's more exciting to me is that ideally, there's no code changes. So we're not asking you to go rewrite your applications. We've kind of done that for you on the Spring side and enabled that as a property. So this also works with native images, which is really nice. So that's kind of one use case. Another use case might be, hey, I have an application that is doing some kind of scheduled task, right? Usually a scheduled task is, hey, I'm going to go get some data from a database or from another service. Again, those are blocking. So that's another good use case for it. Where it doesn't make sense is if we're doing purely CPU-bound execution, or we're already using reactive-based applications. You can turn virtual threads on in these environments, but you're really not going to see any benefits from it. So I think one of the questions that I was asking when I started hearing about this, and I'm sure it might be going through your mind, which is, okay, well, do we still need reactive programming? For me, yes. So a couple things. One, Spring Web Flux is really an architecture for stream-based processing, dealing with large data sets, dealing with backflow. Also, those two other JEPs that I talked to you about, structured concurrency, and I'm forgetting the other one, but those two, the idea of structured concurrency is something that reactive programming does well. Like, hey, I'm going to take in a request, it's going to call 3 services, and then I'm going to aggregate the results back to you, right? Kind of joining those together. So I still believe that there's a reason to pick reactive programming, But if all you did was pick reactive programming to solve that scalability problem we talked about earlier, whether it was hardware or asynchronous, if all you're doing is picking reactive programming as a scalability mechanism, I believe virtual threads is going to offer another solution to that. Cool. A couple more things. The new client abstractions, the REST client. So a quick history on client abstractions. This is really an idea of like, I'm in an application and I need to talk to another service. So we've always had something called the REST template. The REST template, you're able to use it, talk to another service. There's one of the big problems with the REST template over time is that the API has kind of grown out of control, right? And if you look at the documentation, it says this is not deprecated, but it is feature complete, which means we're not working on it anymore. And the reason for that, it just got to a point where there are so many overloaded methods. When you say REST template dot, I'm like, what method should I be selecting here? There's so many options there, and it's very confusing. So what came out of that was when we got into reactive programming, a new client was created. It was called the web client. And the web client offered this nice, fluent API. It was easy to use. It was easy to understand. There wasn't all these like overloaded methods. And so we found that the GraphQL client was built on top of the web client. We found that a lot of people, including myself, were bringing in the web client into an imperative program because I just wanted to be able to use this nice fluent API, right? So what happened was we came up with the REST client. The REST client was added to Spring Boot 3.2. It's similar to the web client in the fact that you get this really nice, intuitive, fluent API. There's not a whole lot of methods. We'll see an example. When I use it, when you hit REST client dot, it's like, here's a get, a post, a put, a delete. It's like easy to understand, right? And then there's also HTTP interfaces, which we'll take a look at. I'm going to jump past this just so we can get into some live coding. This we'll see when we get into it. So there's also the JDBC client. So there's been a history of like, here are the different database levels of abstraction that we can use. So if you want to write an application that talks to a database in Java, you can use JDBC API, right? That's not the most friendly API in the world. It's been around since like 1.1 or whatever, so that's always there. When you're in a Spring application, though, we had this abstraction level on top of that, which is the JDBC template. So this is another way to be able to like easily talk to a database, persist, read information. But again, it suffered some of the same fate that the REST template did, just kind of overloaded methods everywhere. There's like this row mapper thing that you have to deal with, to like map columns to object fields. So that got a little confusing. Spring Data comes along and gives you another level of abstraction on top of that. So you can just write a repository or an interface, get it turned into an implementation at runtime for you. And then in 3.2, we added the JDBC client. So the JDBC client, similar to the REST client, just gives you this nice fluent API to work with databases. And this is all about picking the right level of abstraction, right? Like if your team knows Spring Data, JPA, and that works, great. If I was handing this off to a new developer who just wanted to write SQL, I'd probably give them the JDBC client because it's intuitive, and if they've written this in another language, this might seem familiar. So we'll see some examples of this. I'm not going to bore you with the slides. We'll get into some demo. So before I get into some live coding, any kind of questions on some of this stuff so far? No? Yes? Yeah, you need Docker running. You do need Docker. So we don't support Podman right now. The Docker Compose requires Docker Desktop to be run. That's a good question. I would think so, but I'm not sure. All right, let's do some live coding. So I have a GitHub repository here. If you want to go here, you can kind of follow along. It's github.com/danvega/sb3 for Spring Boot 3. I have a little bit of an agenda in here, so I remember not to miss anything. But these are things I want to run through today. So to start a new project, you could go over to Spring Initializer at start.spring.io. One feature I thought I'd show you here is you can actually, I'm going to open this link here. If you go down to share, you can copy basically all of your settings for this. So I'm basically saying, hey, I'm sharing this project with you, and it fills all of this in for you. So we're creating a Maven project on 3.2.3. I'm using Java 21 because maybe we'll be able to get into some of the virtual thread stuff. I'm using Spring Web, the PostgreSQL driver, Docker Compose support. So again, if we just look at Explore here, this is going to write a compose file. So based on the services in there, it's going to write. Yes? Oh! All right, let's do this. That's better. Not readable, but better. All right. So this is the compose file. It basically looked at what are the other dependencies here. And it said, okay, you want a Postgres database? I'll go ahead and set that service up for you. And it maps a port for me. So I'm going to just kind of flip over. Oh, that's right. That stopped before, right? Let's see. All right, can we see that in the back okay? All right. Okay. So I want to go, I'm writing this application that revolves around the idea of a blog post. Bigger? Okay. Yeah, let me go. Let's see in the back here. Oh, that's why. Because I had it on a bigger font before it decided to crash in the middle of our party here. One more. Okay, is that a little bit better? All right, cool. Sorry about that. Okay, so I'm writing this application around the idea of like blog posts. So I have this, first thing I want to do is just go ahead and start the application. We'll look at our compose file. So again, it creates this compose file. One of the things it does, it sets up a port. So Postgres is going to run on 5432. I'm going to make one change. So in the Docker world, what? In the Docker world, right? If you leave one port, it's going to map it to a dynamic port. Normally, we don't care what port it's running on, right? In this case, I do want to know what port it's running on because I want to connect to that database when it starts up. So I'm going to go ahead and run the application. And if we look in here, we see that it's starting. It looks for that particular compose file. So it's right here. It's saying, oh, I see the compose file. I'm going to go ahead and start up the different services. And again, I think I can show you that I have Docker Desktop running. So it might just take a second this first time. And then it goes through and it starts up these services. So now I have a Postgres database running. My application started, and we could connect to the database. There's actually nothing running in that database yet, so we'll get back to that in a second. So now in my application, I have this post class. So who's written a class like this? Just a simple class, but it has 4 fields in here. And look at how many lines of code that is. 76 lines of code for a simple data query class, right? But we're on Spring Boot 3. We are no longer bound to Java 8. We are in the exciting world where we get to use some fun things here. Oh, why did that do that? So we're going to create a record. So we can use records now, and we can say integer ID, integer user ID, string title, string body, right? So now we have this record. So we've taken our 76-line class into this nice few lines of code for a Java record. I'm going to go ahead and put these on separate lines. And I'm going to go ahead and add something here. So I want to do some validation in this post. I want to make sure that when a post gets created, that we don't have an empty title. So I'm going to go ahead and use bean validation here and use the not empty. So not empty. And I just wanted to do this to point this out to see that we are in fact using the new Jakarta namespace, not the Java X1. All right, so I have a post. Let's come back here. All right. Now I want to go ahead and just make sure that we can set up a database, to set up our database schema to talk to that database. So what I need to do is I need to define a schema. So I'm just going to go ahead and create this. It's going to be basically the same as that post that I just created. With this in place, I just need one more thing. So if it's an embedded database in Spring, we will automatically see that schema file and run that for you. If it's not an embedded database, here we're using Postgres, we just need to say that, hey, go ahead and init that for me. So I would say spring.sql.init.mode equals always. And now when I restart my application, it's going to run that schema for me. So hopefully, if nothing goes wrong, we have a database up and running. We can actually connect to it here in IntelliJ. So you can use whatever database tools you're using, but I should have a database running now. So I should be able to say, let me create a new database. We'll call this localhost. It's running on 5432 because we've set that port explicitly. And I don't remember what I did. I think it's, I have good memory. Yeah, let's come back here. So I'm going to go to my compose file. We are creating a blog with admin and secret. So let's do that. And this is blog. And let's go ahead and try to connect. And there it is. So we have a database. We have a table in there called post. There's just no data in there yet. So let's talk about getting data in there. So I talked about the different levels of database abstraction, right? So I have this post repository class, and I don't want to do that yet. I need to turn GitHub Client Copilot off. So that all those little like suggestions are coming from GitHub Copilot. Let's just say disable for now. And now I have this repository class, and I want to be able to read information from the database or persist information to the database. So as I said, I'm not going to make you watch me type all of this, but we used to use something called the JDBC template. So we can get an instance of the JDBC template. We can do things like call update. We can pass in this string to say insert into a post. When we are trying to map things to objects in our system, like we are when we're trying to find all the posts, we have to use this thing called a row mapper. A row mapper is a functional interface. It's a way to like map the columns to our object. Sometimes this can be a little bit confusing, so we're using a Lambda here to do that. But again, just looking through this code, this is pretty simple, but this can get pretty verbose. So now we have the JDBC client. So if we look at that, so now when we want to ask, we can ask for an instance of the JDBC client. This is auto-wired in Spring Boot 3.2. And when we want to do something like find all, we just say, hey, JDBC client.SQL, here's the SQL that I want you to run. In this instance, I want to run query. That says, hey, go ahead and run that query for me. What we're going to map it to is a post. So we have that post record. We can map right to that post. And hey, what I want returned from this is a list. So I don't know about you, but the first time I saw this, I was like, wow, I've never written this before, but just reading this is readable to me. I like this Fluent API, easy to use. So we have a whole bunch of methods in here, right? No, so in Spring, if you only have a single constructor, it is basically implicit. So you can think of it like this, but this is happening for you behind the scenes. So that's kind of that's one of the new client abstractions. The other kind of abstraction on top of that I just want to quickly show is Spring Data. So now another abstraction I can do is say, just create me a post repository that extends something like the list CRUD repository. So the list CRUD repository takes a type and then an ID type, which in this case is an integer. And because of that, I get all of these methods. So one of the other additions in, I think it was 3.0, was the addition of list CRUD repository. So there used to be the CRUD repository, but it would return an iterator, and you had to like do the dance to get the things back that you wanted. So now there's a list CRUD repository. You could say, just give me a list of those things back. So basically what we're getting is all of the CRUD functionality that we would want out of the box without having to write all those. Again, picking the right level of abstraction that you want to use. So I'm going to go ahead and clean that up. So now we have a list. Now we have a post repository. I can go ahead and insert some data into the database. So what I'm going to do is create a command line runner here. The command line runner runs after the application context has been created. So I can say, give me that post repository, and I can say repository.save, and then I can say new post. So it takes an ID, a title, so hello world, and then this is my first blog post, right? So now if we did everything correctly, we can go and rerun our application. Yes? In where? In the JDBC client? So in the JDBC client where we had the post record, though I did that to absolutely align up with the post record. If it doesn't, you can still write a row mapper to kind of align all those things. But I wrote a record to line up with those columns. I have an issue here. Oh, yep, we know why. Okay, so this is just a Spring Data issue. Let's do this again. And let's just add one thing here. So now that we're using Spring Data, we need to set a couple of things on here. So I'm going to say add version. And this is really just a Spring Data JDBC thing. We'll call this version. Let's go ahead and try. Now that I did that, I need to change one more thing. So this is how it keeps track of, like, is it a new one or is this something that I'm updating? Oh, still having an issue, huh? All right, that's all right. I'll hand wave and we can move on. Yes? So that's what, oh, you know what? Oh, we missed. Yep, good catch. So that's how it tells by what the primary key is. So that was probably our issue. Yay. All right. So now if we go ahead and look at our database, now we have our one record in there. So those were kind of the different levels of database abstraction. I want to talk about the other new client in Spring Boot 3.2, and that is the REST client. So I'm going to close this up. I'm going to use my handy-dandy JSON placeholder service. This is a public API that you can basically hit and get a bunch of resources back, one of which is posts. Now it will make sense why I made that post record look like this. Here's a API that we can hit that will return 100 posts. And so now I want to talk about how we might talk to that, right? So in the past, I might have this post client, and I might have used something like the REST template. Again, we talked about this earlier. The REST template has a lot of these overloaded methods, like, let's jump in here. So if we look in here, and we look at the structure, oops, there is a bunch of methods in here, right? Things like get for object, get for entity, head for, post for, delete for, exchange, all these overloaded methods. So it can be a little confusing on like which one to use, right? In this case, this one will work, but again, this is pretty verbose for a single method talking to an API. So I'm going to clean this up a little bit, and we're going to use the REST client. So we can say private final REST client, and REST client, and I'm not going to get this through, I'll show you a quick thing. So the REST client is actually an interface. So if we look at the REST client, there are some static factory methods in here. So if I want to get a new instance, I can call create. I can call create with a base URL. But there's also this REST client builder. And if we look at builder, builder is an interface, and there is a default REST client builder. And an instance of this will get created in Spring for us. So we can basically just ask for this. We can say, go ahead and give me that builder. And now I can say builder. Base URL, so we want to call the base URL of this service, and I'll go ahead and pass that as a base URL, and then I'll call build on this, and now I have an instance of the REST client. So what does this do for me? Now if I want to get a list of posts, I want to say a list of posts, say find all. Here's where I wanted to really get to, right? So now when I hit REST client dot, now I'm not sent all these methods in the API that are like overloaded and I'm very confused. Now looking at this, I know like, is this a post? Is this a get? Is it a delete? In this case, it's a get. So I want to call get. And then what is the URI? The URI is going to be whatever is after that base URL. So in this case, that was /posts. Then I want to say either retrieve or exchange. So retrieve is a simplified version of it. Exchange gives you a little bit more control over the request and the response. But for this case, retrieve is fine. And then I want to say, okay, what do I want to turn that body into? In this case, I'm going to use something called a parameterized type reference. And that should be good. So I will return that. And now I can get a list of those. So this is going to talk to the JSON placeholder service. And we should be able to get a list of 100. What I'm going to do with that is come back to our application. And instead of saving this one post, I'm going to use the repository to save a bunch of posts. And what are those posts? I'm going to say, let's use that client that we just created. So I'm going to say post client, and we could say, and actually we could just say post client.find all. All right, so now if we run this, we should be able to call our post client find all method. That's going to reach out to the JSON placeholder service, get 100 of those. We're using that repository. Again, we haven't written a save all method to take a list of posts and send them to a database. That's being done for us at runtime by that. So now if I look in here, it should be 100 records. All right, so one more kind of abstraction on top of that. Again, all about picking the right abstraction. Maybe I don't want to write this code. This wasn't too bad, but hey, I have a bunch of methods to talk to this API. Maybe I don't want to write the code at all. So what we can do is we can actually get rid of this. We can turn this into an interface. And we can say, so there's an HTTP exchange annotation. There's also specialized versions of that, one of which is get exchange. So I can say, hey, I want to call posts. So again, this is an interface. We're just writing the method contract. We're not writing the implementation. And this is going to return a list of posts. And we'll call this find all. So now I've not written the actual implementation. We can use this post client. You do have to set up, there's a little boilerplate for this because you have to like use the REST client and set up that base URL. I never really write this. I just come in and use like a live template for this. But again, it should look familiar, right? We just use that REST client. It uses one of those static factory methods to create a REST client with the base URL. And then what we get back is a post client. So down here, now we're going to get a post client. So now this code should work exactly the same. The big difference for me is I didn't write any of that code to talk to that JSON placeholder service. All right, any questions so far? All right, I'm just going to show off one more little thing, and we'll call it. So, who's heard of Open Rewrite? All right, couple people. So we've talked about all the cool things in 3.0, 3.1, 3.2. Some of the customers that we've been talking to are like, that's great, but we got to get there, right? We got to be able to upgrade. We're still on a lot of applications that are on Java 8 and Spring Boot 2.7. How do we get there? One of the things we show them is Open Rewrite. So Open Rewrite is a way to run these kind of recipes. These recipes are instructions to do a certain thing, right? I'm going to show you a simple example first, and then we'll move to like the Spring example. So I have this weird class that I've called the string calculator. It knows how to take a string with two numbers in it and either add or subtract them. Nothing really interesting here, but I have a test for it. And in this test, and again, I wanted to like really simplify this one. There are some assertions here, but it's using assertions.assert equals. And maybe we want to use a static import for this, right? So if you head over to Open Rewrite, you can go through here, learn a little bit more about Open Rewrite. There are a bunch of recipes, so you can learn like how to run recipes. You can like migrate to Java 17. You can migrate to Spring Boot 3.0. One of the recipes that I found was use static import on JUnit Jupyter assertions. So if you go down there, you can run this from like Maven or Gradle, but there's also a definition. So there's a YAML file that defines this recipe. There are a whole bunch of open recipes on Open Rewrite. You can find recipes elsewhere. You can write your own recipes if you want. These are open source. You can go in and look at how these are written and write your own recipes, because a lot of that we've seen with customers is, hey, this is going to get me 80% of the way there, but we still have some other things in our organization that we need to be able to migrate. And one of the things that you can do is write your own recipes and run them within your organization. So I've imported this recipe in here. So it says use static import. So in the newer version of IntelliJ, this Open Rewrite plugin is bundled into IntelliJ. If you're on an older version, you can just go ahead and download the plugin like you would any other plugin. But with it bundled in here, I can come in here and say, okay, let's go ahead and run that particular recipe. And so it's going to run that and fail. I think this is because of this. Yeah. Let's just delete that. We don't even need that for this. Let's try that again. So run static imports. Let's see if that works. And this one's pretty simple, but in larger ones, you'll be able to see like all the steps that it takes, because it might be a combination of other recipes. So now I can go ahead and look at the diff for this, and it basically went into my POM. Oh, whoops. It should have, sorry. So now it went in and added that import static statement for me, and now you can see it's no longer using that assertions.assert equals. So that's on the very simple side, just to see how a recipe goes. But there are recipes around upgrading to something like Spring Boot 3. Now this one is going to be a little bit more complex because, as we said, we are baselining on Java 17. There's the Jakarta change. There are a whole bunch of changes that go into that, right? So if you don't want to have to upgrade your applications manually, you could run a recipe like this. And you can see this particular one, it's made up of other recipes. Like, hey, I got to move to Spring Security 6. I got to change the version of Java or Jakarta. So there's a lot of things going on. Properties change from different versions of Spring Boot. So if you can come in and you can run this, in this case, I don't think it's going to do much. It's just going to change my POM file and change the version of Spring Boot that we're using and the version of Java that we're using. But if this runs correctly, we should see that in the POM. So if we go back to the POM, this is now using Spring Boot 3.0 in Java 17. So if you haven't taken a look at Open Rewrite, it's a pretty cool project. No. So what I normally do with Open Rewrite recipes is I branch out and I say, hey, I'm running this recipe. This is a branch, because then you could see the changes that were made. Yeah, so I probably wouldn't do this on main. I mean, you could always roll back. Just don't push it. There you go. All right, so that is Open Rewrite. Yes? I have not. I've not seen one. Yeah, and I know there's not one on the Open Rewrite thing. I would have to ask this. I don't know where Glenn is. I'd have to ask the Spring team. They have an internal, I know they have a bunch internally that they have given out to customers. I don't know which ones are made public, but I can always ask for you, but I haven't seen one. Why do you need to? So I love the REST client, but if I'm upgrading, I'm not touching that stuff. I'm going to use the REST client in any new code I write, but that code still works, right? No, so they're both blocking, but what happens is, let's take a look at this real quick. F1. So if I'm in a application, so right now, by default, this particular application is blocking. So if we're talking to another service, we're using traditional threads, we are blocking our application. All you need to do to enable that is Spring threads virtual enabled equals true. And now all the infrastructure underneath the hood is using the new virtual thread executor. Yep. Yeah, anything that goes out should use that, yes. We stopped adding features to REST template, but it's the mechanism underneath the hood that's making the call. So the REST template and the REST client don't actually make the calls out. Even the REST client, it uses something underneath the hood like the JDK client or the Apache Commons client. So that is the thing that's making the call out, not the REST template or the REST client. No, you don't. Yep. I will try and make that more clear, but yeah, because again, that's underneath the hood, that's an infrastructure thing. That's the actual client. And even what I didn't get to is on the REST client. So again, if I'm writing something new, I'm using the REST client because by default, it uses a default HTTP client underneath the hood, but you can swap those out. You can say, I want to use the Apache HTTP comments, or I want to use the JDK client in JDK 11, right? So, yes?
Yeah, maybe my understanding is wrong, but I thought records were immutable, so how do I use it with JDBC?
So with Spring Data JDBC, you can. With JPA, you can't, because they won't work with JPA. But with JDBC, you can. JDBC is different than JPA.
So JDBC client,
So Spring Data JDBC, you can use records with that. With JDBC client, yeah, you can use records there too. Yes, but not just normal JPA. Like you can't say map this to a record because of immutability, right? Yes. I don't know how it works underneath the hood. So basically, any place when you enable that, it's basically using the new virtual thread executor instead of the regular thread executor. It's at, so like the things that had to be changed for that are like things like Tomcat. So it's now using that on the Tomcat level because that's where the requests are coming in from. So the Tomcat is using the new virtual thread executor. And any database call, right? The database needs to be configured to use that as well. Hope that helps. All right. Yep. Not that I know of, no. All right. I will say, though, there are a couple things, not security vulnerabilities, but when I said that you almost don't need to change your code to take advantage of virtual threads, there are some caveats there. If you're using like synchronization blocks, that's what some of those other JEPs are going to like solve for, but most of the time, you don't have to rewrite your code. Okay, so Spring Framework 6.1 came out in November. That is the foundation for Spring Boot 3.2 and 3.3, which is coming up very, very soon, in May, in fact. And again, production ready on JDK 17 and 21. If you want to use the virtual thread stuff, you have to be on 3.2 and JDK 21. Cool. Yes, questions?
Yeah.
Yes.
What do you mean by initial? This is the wording that you guys use.
Yes, so this was initial support for Project Crack. So I don't know what's on the roadmap for that, but it's really just the first iteration of it. I know there's more coming in 3.3, I believe. There's also some interesting things coming. So the AOT stuff that we did for GraalVM native images was not really just for that. It was a precondition for native images, but also some of the things coming in Project Laden. So AOT was a big change there. I don't know what's on the roadmap for Crack yet, so I'd have to look at that. Yep.
For your live demo, did you say that you're using live templates from IntelliJ to push the code in? Okay.
Yes, I am a big fan of live templates, especially live coding. Like you don't want to watch me write all that. It's a great feature. I use it even in my like day-to-day coding. If I have something that I see myself repeating, I will create a live template for that and just put that in there. Like the declaring a REST client and declaring a REST client builder and a constructor with a base URL, that's a live template for me. So, yep.
On the open rewrite thing, is there a way, if you take, let's say, Spring Boot 3.2 recipe, is there a way to have an exclusion list instead of, because it's baseline and it has a lot of things in it, if I want to exclude it, let's say use static input, I don't want it to run.
Yeah, so those recipes are made up of using other recipes. So if you wanted to exclude one, you could. One thing I didn't mention too is like, if you're on something like Spring Boot 2.7 and you want to go to 3.2, one of our recommendations is go to 3.0 first, then go to 3.1, then go to 3.2. Because that change from 2.7 to 3.2 is a big one. So do it incrementally, but yes, those recipes, it's just a YAML configuration, right? It's saying, here's the recipe name, here are the other recipes I want to use. If you don't want to use one of those recipes, take it out.
I'm happy to try more approaches. I think going step by step, it really takes a lot of time.
Yeah.
But if you go,
I had a project that was on Spring 2.4.
Yeah.
I had 3 of them. I ran incrementally like that.
Yeah.
Upgrading 2 of them took longer. On the last one, I took a shot to just run 3.2 directly.
Huh.
And yes, there is more work that you need to do, but it's going to run.
Yeah. It also depends what's in your application, right? Like if you're using something like Spring Security, there were some big changes in Spring Security 6. So like that's something you need to think of too. If you're not using a lot of different libraries, then maybe it is easier just to jump. But that is usually our recommendation. Try to do the incremental upgrades. All right.
what comes out today?
Yeah, we did. Spring Boot 3.3.
Okay, what's in it?
You have to read the release notes. Honestly, I've seen a couple things, but I have not dived into it myself yet. So I think Deshaun and I are going to do a Spring Office Hours on that soon, though. So if you want to check out Spring Office Hours, we will get caught up on that and share it with you.
And sometimes they even loop in a Spring developer in there so you can stomp the chomp too. So if you ask me about Spring Security, that would be a very quick stomp the chomp, all right?
We'll just invite Daniel.
Yeah, exactly. All right, any other questions? Comments? All right.
All right, well, before anybody leaves, thank you guys so much for having me out here. I've always wanted to come to an Atlanta Jug. So it was really awesome being here tonight. Thanks for coming out and spending some time with me.